In the previous video, what we did was we went through the basic ideas, the real goals behind this planetary motion unit. And in the PowerPoint, I have them listed out in some detail. But just to summarize briefly, one of the things we want to do is understand the way that technology leads to better data, which leads to better models. Another thing that we want to look at is the different ways that science is conducted in terms of normal science, which is where you have a model and you just kind of work on improving that existing model, and then revolutionary science, where you abandon the model that you've been working on and you go to a completely new one. And the third thing that we're going to really focus on is a particular type of revolution, or a particular instance of a scientific revolution, which is the Copernican revolution. And we want to understand the reasons why that Copernican revolution came about. And it came about specifically because of better technology, which led to the better data and the better models. But it also came about because we understood a way of doing observation and analysis that was different than what had come before, and this was the scientific method of doing things. So it's important to understand that as we go forward that I'm first of all going to focus on kind of Western understanding, and that starts in Greece. And in Greece, they had mathematics, which was, making models and that type of thing, and doing calculations to figure things out. And they had natural philosophy, which would later kind of evolve into science, but they didn't, strictly speaking, have science. So they were sometimes really good, but they were sometimes really bad, and they were sometimes completely off the wall. And a lot of times somebody said the right things, but they had no way of really distinguishing between what was right and what was wrong, or what was more accurate and what was less accurate, because they didn't have a scientific culture. They had a philosophical and mathematical culture, which are different. And so I have a couple slides, the Greek great idea fun time, because they came up with some great ideas, but the ways that they came up with them were not necessarily fantastic, and what they decided on as being the best models were not actually necessarily what we would today consider the best models. So some of the things that influenced the Greek ideas were their cultural lenses. And what I mean by this is the way that they viewed the world through their culture influenced the models that they came up with. And one very important cultural lens that they had was the idea that the sphere was the absolute perfect shape. There were a number of shapes that the Greeks really liked, but the sphere was tops in their books. This was the ideal shape. Heavenly bodies were associated with their gods. For instance, Mars was a god, Jupiter was a god, Venus was a goddess, and so on. So the planets, and that seems to be the one that I left off here. I really meant for this to say planets. Planets, sun, and moon were related to their gods. So they were very important in Greek society, and they had this sort of esteemed place for them. The other thing was that beauty, or aesthetics, was very, very important in the Greek culture. So if they came up with something, they wanted it to be a beautiful something. They wanted it to be very pleasing, a very pleasing idea, rather than necessarily the most accurate idea or the best idea. Because to them, this triumphed over, for instance, accuracy. So some of the observations and conclusions that they came up with that were tinged by these cultural lenses was, first of all, the Earth was spherical. And this was actually an instance where the idea of the sphere being the perfect shape really worked out to the advantage of being right, or being closer to right, because the Earth isn't exactly spherical. It's oblate, roughly. But it's pretty close. It's a pretty close idea. And they actually measured it. You can look up the ways that they did this, but it was pretty ingenious that they got pretty close to the actual size of the Earth. And one of the things that this does elucidate is that nobody really thought that the Earth was flat. That's kind of a misconception that we have about the misconceptions of the past. The Greeks knew that the Earth was spherical. Most seafaring cultures knew that the Earth was spherical. It was maybe some inland people didn't quite realize it, but a lot of the seafaring cultures knew the Earth was spherical. Another thing, by extension, if you think that the Earth is a sphere and you've measured its size, and then you look up and you see these disc-shaped objects in the sky, the moon, the sun, the planets, they look like circles, it's reasonable to conclude that they're not actually flat objects. And it would be a little bit weird if they were cylinders. It's not the perfect shape, anyway. So they decided that the moon, the sun, and the planets were all spherical. And because of their place in the heavens and their place as being related to their gods and goddesses, they also assumed that the moon and the sun and the planets were perfect. And, this follows and it makes sense. And if you look up at them, we don't necessarily notice any weird projections off of the surface of the moon. You see things with the moon, shadows, that type of thing, dark spots, light spots, but that doesn't mean that it's not perfect. So one thing to bear in mind is that the distance that the moon is from the Earth is very, very large, and it's difficult to conceive of that distance. So the Greeks didn't necessarily realize how far away the moon actually was. And so if there were imperfections with the moon, you would see little mountains jutting off the side of it, and that type of thing. Another consequence of the whole sphere and beauty idea is that the orbits were circular. They had to be circular in order for them to be perfect. And the last one was that the Earth was in the center of the universe. And both of these two, today we know that they're not quite right. But if you can put yourself in the position of making the observations that were made by the Greeks, it doesn't seem very far-fetched. In the previous lecture, I showed you the motion that the stars were making, particularly if you looked at the one near Polaris. You hopefully remember the stars swirling around. They were going roughly in circles. And if you look at the path that all the stars take, they're going pretty much in circles. And even Mars, with all of its wanderings, if we traced that path across the sky, it would look sort of like a circle, a little bit off of a circle, but sort of like a circle. And the Greeks didn't necessarily care that it was a little bit off of a circle. That wasn't the major point. The point was that it was roughly a circle, and that was good enough to say that it was a circle. And the idea of the Earth being in the center of the universe, it certainly looks as though the sun is going around the Earth from our perspective. It certainly looks like the stars are going around the Earth, like the planets are going around the Earth. So it's not an inconceivable conclusion to make that the Earth was the center of the universe. The Greeks, though, were not uniform in thinking these ideas. A number of Greeks came up with what were considered unpopular conclusions, and this sometimes led to things like exile or stoning or threats of stoning for the people who came up with these. Anaxagoras came up with a couple of doozies. He said that the sun was a large fiery stone, which meant that it was not made up of heavenly material and otherwise special. He said that those dark spots and such on the moon were actually ravines and mountains, which means that it was much more like Earth than we had wanted it to be, and not quite perfect. And he also claimed that the moon reflected light. It wasn't actually creating its own light that just varied with time, with the phases of the moon. The light that we saw from the moon was just reflected light, and that explained the phases of the moon. So you can see that some of these, while the sun isn't precisely a large fiery stone, it's kind of close. And you can see that some of these ideas were actually pretty good, but the thing is that Anaxagoras didn't have very compelling evidence. Obviously, some of these would be hard to get compelling evidence for. You almost have to go to the moon or get really good images of it in order to make this claim stick. This guy named Heraclides of Pontus suggested that the Earth might actually rotate and the sun stays still. And this makes sense from a physical standpoint in that it's a lot easier to think of the Earth spinning than a gigantic body spinning around the Earth. If you think about just spinning in place versus running around in circles, it's a lot easier to just spin in place. So the idea was that it's easier to have that happen. The other thing that he did was he made it so that Mars and Venus orbited the Sun. So the Sun was in the center, Earth and Mars and Venus orbited the Sun. And I actually think that this was meant to be Mercury. Sorry about that. Mars doesn't quite make sense. Mercury and Venus orbit the Sun. And the reason why he said this is because Mercury and Venus are only ever appear in the sky near the Sun. Venus is called the morning star, and it's also called the evening star or the dawn star, because you see it in the morning and you see it in the evening. You see it when the sun, just before the sun is rising sometimes, or just after the sun has set. And you rarely see it in any other time. It doesn't appear anywhere but near where the sun is. So Heraclides thought, well, maybe it makes sense that Venus is actually orbiting the sun since it's always so nearby. And then Aristarchus took it one step further, and he said everything orbits the sun. And he made up a model, kind of a tentative model. The only problem was that it wasn't very good. And there are some problems with the whole idea of the Earth spinning. And we'll talk about those a little bit later on. Some things about the Earth spinning that make it seem absolutely absurd. So what we're going to do next lecture is kind of finish up with the Greeks and move forward. But I wanted to just go through some of the ideas that were being bandied about at the time, and to show the range of ideas that were present and how close they were really getting. They just lacked the evidence to really back up some of these ideas.